Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
When major system issues occur, it's already too late. With large-scale problems, it usually takes a while to diagnose the issue, fix it, get it through testing, and get a fix deployed. This is true even for hot fixes, and it's better to try and predict where issues may arise before they happen, to the best of your ability. In this episode, we're going to discuss some thought exercises you can do to find unlikely issues in your system before they happen. These thought exercises won't find every potential system issue, but they will get you about 80% of them, which will give you breathing room for dealing with the more interesting problems. But before we get started, Will, what's been your issue this week?
Well, other than just trying to get business set up and going through the list of stuff I have to do. Because, I still have the old business site. I mean, I just basically revived the old one. And that site is dated significantly. I think the last time I updated any content on there was like 2015. And I pulled that code down.
Is it still in Hexo? Because I remember doing that.
Yes. And it's ancient. Like it's the layout that you did when you were learning. And so there's stuff in there. I'm like, why is it? Oh, yeah.
It was because you asked me to make it the exact same.
Yeah, as the WordPress site. Now I'm like, I don't think that's the way I want it now. But so at some point I'm going to have to fix that. And then I'm like going, okay, well, I need to have some way to track time. I got to find something for that does it accurately and, so I can invoice. And then I'm like, well, I got to get QuickBooks set up. So what does a chart of accounts look like? There's just all this, I got to go to LinkedIn. I got to fix my presence there. I've got to, do better at the networking, all that kind of stuff. So there's just a bunch of like not code related minutia for the most part that I got to deal with. And I'm pretty well covered at the moment. So yeah. So how about you?
Well, we are recording a second episode tonight because I was sick last week. You were too, but I don't think you had it as bad as I did.
I think mine was allergies from all the smoke.
Really? Yeah, probably.
Thanks, Canada. I'm just kidding. It's not y'all's fault. Blame Canada.
Yeah, that's exactly what I was thinking. Yeah. That's South Park. Was that the movie? I think. Yeah.
Yeah. It was definitely the movie.
So I had strep throat and I've been blaming it on you. I was like, you know what? I went to Europe for 2 weeks and I came back. I was perfectly fine. I had lunch with my best friend whose wife is a teacher. And 2 days later, I had strep throat.
Yeah, but like, I think that was the week they were out of town.
They were. She wasn't there, but you were there, and I ate some of your food.
Did you? That's right. You tried the spicy, the camarones a la diablo.
Yeah. So that's it. That's what I've been telling people. I was like, I ate some of his food, and he got me sick. That's what it was.
Right.
I literally slept for 3 days.
Nice.
It was Monday. I got up, and I had a little bit of a sore throat, and I was like, I don't feel like running, so I'm not going to this morning. And then it was getting close to lunch, and I'm like, I don't even feel like going to the gym and lifting, let alone running. So I'm just going to lay down. I told him at work, I'm like, hey, I'm starting to feel bad. I'm going to lay down and take a nap. And when I woke up, I had a fever and took the rest of the day off, slept, woke up Thursday. I mean, I took medicine and stuff, woke up Wednesday, and I was like, or Tuesday. Wow. Yeah. See, it was all a blur. Anyway, I woke up Tuesday and I'm like, I'm taking the day off. I just told him like, hey, I'm sick. I'm going to be off until I'm not sick anymore. I'll let you guys know how it's going. And so I just been like, I was keeping him updated. But yeah, I slept Tuesday. Basically, I got up long enough to take some medicine. And as soon as it kicked in, I went back to bed. So Tuesday, Wednesday, and then my fever finally broke Thursday. So pretty much missed everything. I stayed in Friday and Saturday. I went to the grocery store Saturday. That's all I did.
Strep is pretty harsh.
Especially for adults. Like I did go to the doctor and that's how I know it was strep. But I'm still like still taking the antibiotics, and I've got a few more days left of steroids because they gave me those because I can't take NSAIDs right now. And so they gave me steroids because of the the potential for post-strep glomerulonephritis.
Something with the kidneys.
Yeah, inflammation. They put me on steroids, which is a blessing and a curse. It's been really, really nice having the energy again that I had when have been on steroids in the past, because most people are like, I can't sleep. I'm like, I can't sleep. There's so much I can get done right now. I'm like getting all sorts of stuff done. But the not ever feeling full is annoying. That's one of the side effects, is you don't really feel full. And that's why people gain weight when they're on steroids, is because they don't unless you have personal control over your food, you just eat and eat and eat because you always feel like you're just a little bit hungry.
Yeah. When I was in high school and I was homebound, they had me on steroids for quite a while, which is, looking back on it, I don't think that was necessarily the best decision. But yeah, I gained a ton of weight. Well, that and I was staying with my grandmother during the day because my parents still had to work. And it's like, oh, you're hungry? Let's fry you some chicken and some cheese sticks. It's like, let's let you eat like a child. Yeah, that was not great for the waistline. I mean, at least I had the teenage metabolism to help me out there a little bit, but it didn't help enough.
My metabolism has definitely increased since I lost the weight, and I've done more lifting and stuff. But I'm also I went back to being strict diet, where I'm calorie tracking and stuff. That's helped because now I'm like, all right, I don't feel full, but I know I've had enough food.
Right. And you can track it, and it's measurable. It's objectively measurable, like we were talking about earlier.
Right. Yeah, exactly. I just applied SMART to SMART dieting.
There you go.
Actually, hang on. Let me write that down. That's a really good diet plan. SMART dieting.
Somebody go write an ebook up in here.
Yeah. I mean, for real, dude.
Yeah, there's something there. Run with it.
Yeah. All right.
And everybody email him if you're interested.
Yes. Beej at CompleteDeveloperPodcast.com.
I just send it to neckbeards.
Yes, why not? Will can hear it too.
Yeah, it's fine. Saving money is hard, especially when you got to get that food.
Oh, yeah. Lucas Casadas is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like Complete Developer Podcast, he focuses on helping you to not only establish a real plan, but to take action on that plan so that you can create and live your best life.
Now, guys, investing in financial planning services really comes down to whether or not you can improve your finances. With the help of Level Up, those compounding impact of making better financial decisions will easily pay for itself.
Level Up also has a unique pricing model that will help you no matter where you are in your financial journey.
And what's best is Lucas is a fiduciary for his clients. And that means he's not selling a product, but he's here to guide you to a better financial situation.
And you can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics that you probably face and interviews other IT professionals who share how they navigated their own careers. And you can learn even more at levelupfinancialplanning.com.
Simple systems fail simply. Complex systems also fail simply, but their interconnections with other systems make mitigating failures much more complex. Past a certain level of complexity, system failures are an emergent property of the system. That is, the set of system properties has a set of failure cases that the individual parts don't have by themselves. And what this means is that it is more difficult to predict what can happen and what can go wrong with a system. At some level, prediction is nearly impossible. However, you can predict a lot of the things that are likely to cause problems simply by engaging in a few fairly simple thought exercises. You can greatly reduce the number of unexpected problems that your system encounters.
While it can be tempting to wait until a problem occurs to try to mitigate it, this is fairly unwise in a production system that other people are dependent on. A system failure usually costs money at a minimum to somebody. And the problems can be far more severe than that. I've worked on systems where if it failed, it could be a catastrophic financial thing. Like it's just life ruining for someone, or their identity gets stolen, or some kind of crime happens. I mean, there's a lot of stuff that can go wrong. As a result, it's common for software services to include a service level agreement, or SLA, that dictates expectations about the frequency of system outages, dictates how long it takes to respond to things, and the time expected to complete a chunk of work that's submitted to the system. Even if your system is engineered so that it doesn't completely fall over when a problem occurs, it can still violate an SLA and cost money. The consumers of your application probably have their own clients who have their own expectations, and they've built things around your system. So if you fail, they fail as a result of you. And because of this, SLAs tend to bleed inward from clients to the services they use, and then to the services that those services use.
In contrast to SLAs, systemic problems, including both errors and latency, tend to bleed outward from one service to its clients and then to the clients of that service. As a result, when you're thinking about how to find potential systemic problems, it's often best to think of these problems from two different angles. That is, you need to consider how errors and latency will bleed out as a result of a problem, while also considering how SLAs bleed in to put more stringent expectations on your system than you might expect. In effect, you're dealing with a balance between tolerance for errors and difficulty in error mitigation. Depending on how critical your system is to your clients, these expectations will vary.
In this episode, we will discuss some thought experiments you can do when you're trying to mitigate system problems in a complex application before they occur. While these thought processes can help you with diagnosis, by the time that you're actually diagnosing a problem, you already have a problem. If your employer or your customers have high expectations in regards to system stability, it's probably unacceptable to only deal with problems after they happen. Instead, you need to be able to predict problems up front. And we're going to talk through some common culprits of complex system failure, as well as how you might mitigate their more obvious symptoms.
So the first thought experiment that we're going to discuss is to consider what happens if existing problems scale up. So you probably have spots in the system that already cause a few problems, such as load spikes, latency, and other errors. Think about how the system will respond when there is 10 times the load.
Yeah, this is a useful thought exercise because people are probably aware of problems that resolve themselves, in air quotes. If you're not, then you need to be getting metrics because you have them somewhere. And if you don't know what they are, now's a good time to go find them because you can't really do any of this stuff until you have that.
Somebody is tracking them. And if nobody is, then you can make yourself look really good by becoming the person who does.
Yeah. But a lot of stuff that fixes itself will not do so if there is an order of magnitude or 2 orders of magnitude more load on the system, right? Like it fixes itself because the load drops and it's able to catch up most of the time.
If these problems are issues of scale causing latency, then start figuring out how to either scale the relevant pieces horizontally or adjust your SLAs so that they aren't violated when things get slow.
Yeah. I mean, this is just one of those things. And this is what all these are going to look like, right? You're either going to say, okay, how do I meet the standards that are here? Or how do I adjust the standards down to where I am meeting them? And depending on what you're doing, it's going to be one of those two approaches. The other direction is you may have problems of scale that cause errors or latency. And then the errors are probably scaling errors on a dependency. So like if you're seeing errors, you'll probably also see latency. If you're seeing just latency, then it's kind of a different thing. So if that makes sense, but you'll get latency out of anything. It's basically it's the way this always seems like it works. So if you're having scaling errors on a dependency, you're either going to need to figure out how to scale that dependency, rate limit the execution, it's not generating errors, or adjust SLAs. And you're probably going to have to do all three at that point.
So the next is consider what happens if a required service goes down. especially to things that depend on the service, like second order dependencies.
Yeah.
When you are using fairly reliable third-party services, it's easy to end up in a situation where you don't test failure cases often enough. Even if you started with good tests, corners will get cut over time if the service is stable.
Yeah. And this thought exercise is really handy because as you pile more dependencies up, it becomes easy to miss more complex scenarios. So a dependency goes down, the dependency gets really slow or starts chucking errors out, or something else weird happens, and then the thing that depends on it really wasn't built to deal with that, if that makes sense, because the error cases probably are not as fleshed out as the golden path is.
Yeah, I just pulled out my work notebook and wrote down some stuff that we need to look into. I read when I was reading that, I was like, oh, hey, that gives me an idea.
That's the point.
So I was like, oh, we need to look into that. So yeah, thought experiments right there. Now, if the problem manifests as latency, it may be worthwhile to convert some processes out of band. Also, you may also want to display messages if parts of the system are not working well due to a dependency being down.
Right. So if you say, hey, we're experiencing an unusually heavy load, a lot of times what'll happen is a user will go, well, I can just do this later. And then you're not violating the SLA because they didn't put something through the pipe. It's just a nice way to social engineer your way out of that, if you can get away with it. If you can't, that's a whole other thing. Now, if the problem is creating error conditions, then you have to take those into account. And how you do this is going to depend a lot on what your application actually does. And honestly, you may end up with something like an enterprise circuit breaker pattern, where you just say, hey, this thing is kicking out enough errors, just stop anything from going in there right now until the system kind of resolves itself. And you'll do that because what you don't want is a set of error conditions occurring that cause another set of error conditions, and it starts bleeding through the system. That's a cascading failure, and it'll knock the whole system down in a lot of cases. Or you just get a huge AWS bill and your company goes under. But, small matters.
So the next thought experiment is to consider what happens if a required service becomes excessively slow. So when a system dependency gets really slow, but doesn't completely die, it can often cause cascading failures in the rest of the application. And most developers don't consider this in their designs because, frankly, it's really hard to test and reason about, like, how that's going to affect the rest of your system when something you're relying on works, but it just takes a hot minute.
Yeah, this thought exercise gets interesting really quick because it can often reveal situations where you have a lenient SLA or no SLA in a lower level of the application, and that poses a risk to a more strict SLA at a higher level or further out, essentially. I guess probably shouldn't be using higher and lower when I'm saying in or out.
Probably, yeah. This problem will usually manifest as latency. Not all the time, but usually, since it started that way. In this case, you either want to loosen your SLA and run processes out of band, or you need to keep processes from starting until the problem is cleared up.
Right. And of course, if you have a restrictive enough SLA and you have not had the engineering staff involved in the contract creation process, you may not be able to do this. That's just something to be aware of. Now, if this problem manifests as errors, that actually may be intentional. This often occurs due to implementing an enterprise circuit breaker pattern. So you just go, hey, look, this thing's going too slow. Just throw errors when somebody calls in and stop them from cramming more stuff into the pipe and making it worse. That's still not great, but it keeps the system up. Yeah. And usually you do this so that dependent services don't create a bunch of work or flood the system. So another thing you'll see a lot of times is retry logic in the mix. And if you're doing incremental back off over time, or if you're doing back off with an increment that is kind of, monotonic, like it's constantly increasing by the same amount, 15 of them fail and 10 seconds later they try again, but now there's another 15 that failed because of that, and now you got 30. you can get kind of this avalanche effect on load. So you got to be pretty careful about how you engineer that, I guess is what I would say.
We've had discussions on this around retry logic in previous episodes, several previous episodes where we talked about stuff like that. I remember those conversations.
Yeah, I remember them when the system went down because of retry logic. That's why I harp on that so much, because that was not pleasant.
So the next thought experiment is to consider what happens if a required service starts throwing a lot of errors. When a third-party service starts having problems, it doesn't always just fall over. Sometimes there's an elevated error rate due to some dependency of that service. This is similar to an excessively slow service in that your application may not really detect it that it's down because it's not technically down.
Right. So a great example of this is an HTTP endpoint, right? I can say, okay, let's just do some kind of HTTP request, like a simple GET request, and see if it gets a 200. Well, that's fine until your app is doing post request and it's throwing a 500. Like when you can't actually really test the thing that's going to break, but you're testing something that's good enough for the moment we were looking at it 2 years ago. This is how you get there. And this thought exercise is interesting because as you look into this scenario, you find that a dependency can cause your application to violate its own SLAs without the dependency violating its SLAs, because it's not really down and they're getting stuff gets through once it goes. But hey, like your system is going haywire because of all the crap that's breaking. And this gets worse really fast if your application does retry logic, especially if you have a scenario where errors are being thrown, but the process continues. On the other side, it's like, oh, I gave you a 500 because I couldn't write to the log to say I finished. And you just never know in vendor systems like that. And this will be a plague. Been there before.
Now, this problem will typically manifest as errors in your system. That's often good because it makes it easier to find the problem and can help with setting expectations. However, if your own service is consumed by other services, it may not be ideal to propagate the errors to them.
Right. It's also not ideal to slow down to cut the number of errors because then you propagated the latency.
Yeah.
Yeah, it gets fun fast.
Mm-hmm.
And the problem gets even more insidious when your system has really good retry logic, because then you do get latency instead of errors, and it's intentional, but you probably forgot about it. So you're not aware that it's actually happening unless you have something that's watching that. And this does keep your system from falling over, but it is going to propagate to other parts of the system and to other people's systems.
Mm-hmm. The next is to think about what happens if pricing for a required service increases or their terms change. So sometimes, either due to pricing reasons or regulatory reasons, the ways in which you are allowed to use a service may change.
It can include things like the price of the service. It can, include, hey, we can't operate in your country, right? So if you're a Russian software developer and you were dependent on GitHub, February of last year was probably not great for you, just, simply because you couldn't connect anymore. And all of a sudden this thing changed. Well, that's still a risk to your system, and it's something you need to be thinking about. Yeah. In this case, you want to know how quickly you can decouple from the service. And you may also want to have provisions in place for quickly swapping out a service that is either malfunctioning or that is not reachable or whatever.
Yeah.
While you usually are going to be given a grace period for these sorts of changes, a grace period is not guaranteed. And, this is especially, again, if it's across international boundaries, that, there will not necessarily be a grace period because they don't care about you.
This problem may not manifest at all in the system itself, but it is still a system risk that you have to mitigate. So let's say it's a pricing change. It's not going to be a problem with the system. They're going to let you continue using that system. They're just going to charge you more for it.
Yeah. And so stuff that may have worked before, when you got under load, now all of a sudden, hey, this is a really big problem. And if it's combined with errors that do some action that costs money, that's entirely possible. Note that wargaming on this problem will also make it a lot easier to mitigate the 3 previous scenarios that we discussed. So if you're going, hey, what happens if the terms change? Let's make it so that we're not dependent on this one service. Well, guess what? When that service starts throwing errors or has latency and you could swap it over to something else real quick, you're still fine.
The next thought experiment is to consider bulk data load and reporting. The system may run fine under normal usage patterns, but fall over when large numbers of writes or reads are occurring. The most likely culprit here are bulk loading, processing of data, and reporting. They both tend to come in waves and are easy to miss when looking for problems during normal system usage. A good example of this is around tax season in the United States.
Yeah. And this has happened at most places I've worked is, the system has been fine February, part of March, but most people don't file their taxes till the last minute. So like as you start getting into early April and everybody starts pulling reports at the same time and they're in a hurry and they're panicked and they're stressed because nobody likes tax season in the US anyway, your system will get under load and they'll retry things and you'll get these spikes of stuff. And those tax reports probably haven't been hit very much since last year. They certainly haven't had that kind of load since last year. And you may have refactored heavily since last year. Let's just say that I've been there literally every place that had paying customers that could write stuff off on their taxes from us. This has happened. Now, an excessive number of reads is usually, not always, but usually going to manifest as some form of latency. That is, they just slow everything down. But it can occasionally do things like cause deadlocks if other processes are running at the same time. You can also have situations where something errors because it hit a timeout, and that can cascade. So typically, this is kind of a heuristic, but like don't necessarily trust it. Like actually look at your data. Don't just go, oh, it's too many reads.
An excessive number of writes will also create latency, but in Will's experience, as he put in the notes, is usually paired with an elevated number of deadlocks and other timing issues, which, yeah, I've kind of seen that with bulk loading of files when I was working on a file management system before.
Yeah, that's a good place for it.
We actually had to switch out, like separate out the bulk loading from just the standard usage. And so like there's a separate process for bulk loading, and it ran more like a message queue. When we did that, it fixed a lot of problems.
I was at one place where we did that and we thought, okay, we fixed it, right? But yeah. The way we implemented the message queue was not smart because everything in the system that went to an out of band process went through the same message queue processor.
Oh, yeah. No, we didn't do that.
So that wasn't hot.
Yeah.
But it was obvious.
We didn't do that. And it was a few months after implementing that I ended up moving to a new job. So last I talked to him, because I kept in touch, that the system was working well. So, but I've kept mostly in touch with the front end guys because I was the back end guy and the other one retired. So
yeah,
I don't know the new ones on that one, but yeah, they're telling me it works. So that's cool.
Yeah. And if you want to fix these, you need to consider moving reporting to its own reporting system, which you should be doing anyway, most of the time, just because the way that data is accessed for reporting and stuff, like you don't want that in your OLTP system for the most part, unless it's really small. And bulk data processing probably needs to go out of band and get rate limited. So it's like, okay, if you put 1 million records in here, you don't get to pull the whole system down just because you did that. This is especially important when you got a multi-tenant situation, because you'll always have that. There's always that one client that's like, I'm going to load all my data right now, or I'm going to process a bunch of stuff through the system and I want quick results, but it kills everybody else's stuff.
So the next thought experiment is to consider what happens in cases of extreme load from a lot of clients on your front end and public API services. In many cases, when your system is publicly exposed to the internet, it will either come directly under attack or be used to attack another system. You might also have a natural spike in traffic.
Yeah. I've worked in places where, we thought we were actually being DDoSed, and it was actually a good thing for the company, but it was indistinguishable from a DDoS attack. So like you really, like the intent doesn't matter as much as you think it does. What's the old military phrase? A friendly fire isn't. It's kind of one of those things. If a sudden spike of traffic includes a large number of new clients, or if you just invalidated all cache data for some reason, like say you deployed, then certain parts of the system are going to get hot. And it usually happens to the parts of the system where you've already made some allowances for load. So for instance, you're like already caching here, but you've invalidated everything in the cache. Here's the user's permissions. And you're checking that on every request or something crazy like that, or some big table that you're loading into a cache.
Now, while caching within the web browser can improve performance for an individual user and improve aggregate performance of a system, it may not be enough if a lot of the same requests are being made by different clients. In this case, you may want to implement a second level cache to smooth this out. This also may be required deeper in the application.
It may also be wise to warm up the cache upon deployment if you know certain data is going to be requested by a lot of clients all at once and it's not in the cache. That can get a little tricky at times. I've seen situations where a lot of relational data was cached. It's like, okay, well, we're invalidating the cache for these particular entities, but how do I get those entities back in the system in a way that isn't going to overload the cache because we can't load them all? This is a very interesting game to think about. You should also consider, as the next thought experiment, consider how your application responds if a caching server is not available. Again, this is a dependency just like anything else. And cache servers occasionally die. Some people's cache servers die a lot, or they'll have performance issues, or they'll kick out a lot of errors. So sometimes it's like, okay, yeah, the cache server's not down, but it's taking longer to respond than the database does.
Mm-hmm.
Well, that's not great for the application.
No. Usually data that isn't in the cache server will result in a cache miss and a call to the underlying data source. While this is fine in normal use, you do need to make sure that you have a timeout for this operation and that you have a sensible policy on errors.
Yeah. And therein lies the rub. A sensible policy on cache server errors is something you're going to have to ponder for a while. And whatever you come up with is not going to be considered sensible by the next person that looks at it. Mm-hmm. You can have 5 people on this project and you will have 6 different opinions. It's unfortunate, but that's kind of the way it is. If you treat an error purely like a cache miss, then any consistent error in the cache server is going to cause a cascading failure of the rest of the system because it's going to overload the back end. Right? Because you got that cache server there for a reason. Whereas you probably don't want every last thing to fail because of a cache outage.
If you have several cache servers in a load balancing configuration, you'll also want to make sure that a server that is experiencing problems is quickly evicted from that rotation.
Yeah. I've seen cases where you had several cache servers and one of them was malfunctioning periodically. And it's in a load balancing rotation. And so you just get this little burst of errors and then it goes away. And then you get a little burst of errors and it goes away. And it really annoys the users, but like in your metrics, it takes a minute to figure out where the problem actually is. Now, if you got tools like AWS and stuff, they've got a lot of things to catch this sort of thing. I'm talking like this is old school, like manually implementing stuff, putting it on servers in a data center that you own the server, which a lot of companies still do, by the way. Not everybody's on the cloud. Now, the final thought experiment is consider how an insider might try to break the application. So think, how do I kill my app? It's really useful as a thought exercise to figure out how you could intentionally knock the system over other than just dropping the main database. This thought exercise will often point out deficiencies in the system that are a bit less obvious to outsiders. And it's really useful for shaking things out, essentially.
Now, for instance, an insider might know that a particular database table has poor indexing and that inserting a lot of records there will cause various parts of the system to fail. Or they might know that a particular job running during a system spin-up will cause lots of errors.
Yeah, the point here is to look for weak spots in the system, both as a way to mitigate internal threats, but also as a way to mitigate unlikely threats. Right? Because this is not just, hey, normal system operation thing. It's like, it's just sort of like, I can't remember where that bridge collapse was. There was, and it's always in a discussion in like engineering groups, but there was some bridge somewhere and there was like a resonance frequency that happened and it just hit the bridge right and it just tore the whole thing up. And there were a lot of cars on it when it happened. I forget where this was even. I want to say it was out west somewhere, but I'm not sure.
I think I know what you're talking about. Yeah. I remember reading about it.
Right. Like that's an unlikely event. But if an engineer had said, okay, what is the resonant frequency here? If I wanted to break this bridge, how would I do it? That'd be a heck of a way to do it.
That's why we have QA.
Right. But this is more like developer oriented breaks. Right.
Yeah.
Like QA should be catching a lot of this stuff, but at the same time, as a dev, you have to think about the stuff that they can't catch.
Like as a developer, you don't want them to catch stuff because you want to have thought about it beforehand.
Right.
But as my position on QA has changed as a lead, because leading a team, I'm like, I want them to catch stuff because I know as a developer, even as like thorough as I was, like as a developer now, as thorough as I am, I still miss stuff.
Well, yeah. I mean, it's like being an acrobat. You want a safety net, but you also don't want to fall.
Right. Yeah.
You know, like those are two separate operations, but they're very, very closely linked. You know, like I don't want either situation to happen, but I definitely don't want to make a crater with my face. Yeah. So it's very similar. One thing I've noticed with things that work well as insider threats is that you can usually do these things with a configuration change. Usually the way to avoid this type of problem is to actually have systems in place to catch configuration drift. That's the most common case. Sometimes it's data issues and stuff too, but a lot of times it's just straight up config. You know, because people don't look at that and they don't think about it as much. Like once something works, how often do you look at, I don't know, cache timeouts and, you know, your error system configuration and your database connection pooling settings. Like if you're not fiddling with that stuff, you're not looking at it. But dude bro comes in and fixes it in dev for some reason because, you know, his particular machine was acting up and for some reason it gets all the way out to prod and that takes the system down. Yeah. That's where this stuff comes from. I've done that. I've also done the data thing, you know, where you have some screw up that either deletes an entire table or crams a bunch of rows in there because of a bad query that you didn't think something through, or you didn't realize that, hey, you know, deleted records are also going in here. So yeah, it's very easy to do, but if you look for configuration drift, a lot of times you'll catch the stuff. So guys, you can't prevent every problem in a system, but you can usually prevent a large percentage of them by planning ahead. Again, this is a Pareto distribution. This is the stuff that you think through to catch 80%. And the problem is, until you've encountered enough unexpected problems, it's difficult to expect them. And it can be really difficult to envision how something can go wrong or even have a realistic thought process for thinking about how things go wrong. You know, I wrote this list because I've got a lot of experience. And, you know, most of these are things that I have either been on a team working closely with a team that exploded something in this way, or I have been the detonator cap on this particular one. And you don't really get this kind of experience until you've done this for a while. But if you do go through these thought exercises, a lot of times it's going to point out stuff that you're like, ooh, that could be really bad. And that's what you want, right? Is to understand, okay, either the SLAs propagate badly and my customers are going to be mad. It's not necessarily going to kill the system, but it could kill the business, or it could kill the system, and kind of looking at it from both ends of that. And, you know, again, this doesn't fix everything, but it can give you enough breathing room so that when something comes up, you have the capacity to deal with it, and management's not mad at you because the system's falling over all the time already. So that's pretty much all we got.
If you have a question or comment, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons. For references, show notes, and extra tips and insights, be sure to check out the website at completedeveloperpodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/completedeveloperpodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons. You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.completedevelopernetwork.com. Thanks for listening. See you next time.